Okay, our last two problems are talking about codominance. In codominance, both traits are dominant. They show up. They are exhibited, but they're exhibited together. They are co meaning together, dominant. And blood type is one of the main things we talked about being a codominant trait. The A allele is codominant with the B allele. O would be the recessive allele. A and B are codominant. Codominant, for example, would be if you have a white bunny and you cross it with a black bunny and you get a white bunny with black spots. The white is totally there. The black is totally there. They are both dominating together. Okay. We previously talked about incomplete dominance, and that would be a case where neither one of them are dominant. If we crossed our white bunny with our black bunny and we got gray bunnies, that would be a blending. That would be an example of incomplete dominance. Codominance is different. Both of those original traits still show up. They just show up together. So if you have an A allele and a B allele, then you will have A, B blood. You'll have both the A antigen or A protein and the B antigen. 7 says a woman is heterozygous, A negative blood, and a man is AB negative. What is the probability that the child will be B negative? Well, they're all negative, so we're not going to worry about the negative, but we'll do a Punnett Square for the AB types. Okay. And this is what our Punnett Square would look like. Heterozygous for A would have to be heterozygous, you would have the dominant and the recessive, so the A is dominant, O is recessive, so to be heterozygous type A, that would be AO. And then AB, of course, is A and B. So we would get AA, a type A, homozygous type A here. AO would be a heterozygous type A there. And then A and B with AB right there. And then a heterozygous type B in this fourth box. And it's asking, what is the probability the couple's child will be type B negative? Well, we have 1 out of our 4 type B. So the probability would be 1 in 4 type B. 1 in 4 would be type B. That would be a probability of type B. Or we could say 25% chance if we wanted to do it that way too. 1 in 4 chance or a 25% chance of being type B. Okay, number 8 says a man and a woman are both AB blood type, with A and B being codominant. What is the genotypic percent of their offspring? So we'll draw a Punnett Square for that one. Both parents are AB. Okay, so this is what our Punnett Square would look like for a cross between two parents who are both AB type. We would get AA here. These two would still be the AB, and then the BB here. So we would get a type A blood, a type B blood, and 2 type AB blood. So what is the genotypic percent of their offspring? Well, we have 1 AA, so that would be 25% AA, which phenotypically would be type A blood. 25% BB, which would be type B blood. And then we have 2 ABs, so that would be 25, 50% type AB blood. And that is that for the problems. Make sure you know how to work each of those types of genetic problems. The regular Punnett squares, and then the incomplete dominant, the codominant. Be familiar also with the 16 square box. That would be the dihybrid, di meaning 2. Dihybrid crosses where you're looking at 2 traits at one time. Know that the phenotypic ratio, if we cross 2 parents that are heterozygous for 2 traits, will be 9 to 3 to 3 to 1, 9, 3, 3, 1, 9 dominant, 9 dominant, 3 dominant recessive, 3 recessive dominant, and 1, only 1 that would show the both recessive traits. And we can also use our probability lessons with our probability knowledge to use just 2 of the monohybrid cross Punnett squares to look at 2 traits at one time. And if it said they need to have this trait and this trait, we'll multiply the probabilities of those individual traits together to get the probability of both happening. Okay, so be familiar with those as well. Know how to work these problems, and then go back and study the study guide questions as well.